Good morning. In this video, I am going to discuss about the basics of ray optics. In the basics of ray optics, we can discuss about the basic physics law. First, starting with what is meant by refractive index means it is denoted by the symbol n. It's a very important optical parameter, and it can be defined as it's a ratio of the velocity of a light in the vacuum to that of the material. So it's fully based upon the velocity or speed of a light from one medium to another. And these refractive indexes represented as n. Mathematically, it is written as n equal to c by v, where c is the velocity of light in a vacuum or in air, and v is the speed or velocity of light in the material medium, and it has no unit. Next concept is refraction and Snell's law. What is refraction means? When the light incident onto the material medium, then it bends and enters from one medium to another medium. It is refraction. So we can call refraction is the bending of a light ray that occurs when the light rays pass from one medium to another. This is refraction. Then Snell's law. See, in the diagram it is very clearly given. The ray from a higher medium and it hit the interface and move to the passes the lower medium. So the speed will get differ here. Okay. So the next is Snell's law. So what Snell's law states, how light ray react when it meets the interface of two medium having different indices of refraction. It's fully based on the speed of a light from one medium to another medium. Snell's law states that based upon the speed of a light, it can be written mathematically as n1 sin phi 1, which is equal to n2 sin phi 2, where n1 and n2 are the refractive index of two media, and phi 1 and phi 2 are the angle of incidence, and another one is angle of refraction when it moves from one medium to another. Okay, this is a Snell's law. Next is critical angle, and next concept we are going to learn here is total internal reflection or totally internally reflection. So what is it critical angle means? The angle of incident that causes the refracted light to travel along the interface between two different media. That is, a light ray at an angle phi 1 incident and it passes to the another medium which is called as the refracted ray, and it is represented as phi 2. Once the angle got moved a little higher, at the time the refracted angle is parallel to the interface or a boundary. That at that point the incident angle is known as critical angle. So at an incident angle, if the refracted ray is 90 degree to the normal plane, means that angle is called critical angle. Then once again the angle of incident got exceeds the critical angle. The incident angle is more than the critical angle, means what happened? Now the refracted ray is parallel to the boundary. Once again the angle got increased. The incident angle got increased means the refracted ray now bends towards the same medium. So this is called as total internal reflection. That what condition is the total internal reflection? Total internal reflection occurs when the angle of incident phi a exceeds the critical angle. The condition here is phi a is greater than phi c. At that point, the angle is called as internally reflected angle. The same medium, it reflected back. Okay, this the condition must occur inside a fiber to travel along it. The next is, here I have written the condition for a critical angle. Condition for critical angle means here phi 2 is a refracted ray. Now it is parallel to the normal plane. So it takes 90 degree. After substituting sine 90, it becomes 1. If the refracted ray is 90 degree means we can call that incident angle as critical angle. So in the place of phi 1 I have replaced by means of phi c. Then by mathematical small derivation I got phi c critical angle as sine inverse of n2 by n1. Then here we are having two types of rays inside a fiber. One is meridional ray, another one is skew rays. The skew ray is the lossy ray and meridional ray is the lossless ray. Then is optical fiber modes and configuration. See, a mode is called as the number of path taken by the light rays to travel along a fiber. It will take a number of path it will take. It may be of a single mode or single path it will take, or it may be of a multiple number of path it will take. Okay, so based on the mode we can classify the fiber as two. One is single mode, another one is multi-mode. Based on the refractive index we can classify the fiber as two. One is step index fiber, another one is graded index fiber. So what is meant by step index fiber means the refractive index of the core. We all know that the optical fiber has an inner core and it is surrounded by means of cladding. Okay, so here the refractive index of the core is uniform throughout it and doesn't shows any change along the core, but only shows an abrupt changes at the cladding boundary. This is called as step index fiber. What is meant by graded index fiber means the core refractive index is made varying with respect to the radial distance from the center of a fiber. This is called as graded index fiber. Okay, so if the core refractive index is uniform, step index. If it not so, it is graded index. Okay, and based on mode of fiber we can classify it as single mode and multi-mode. Single mode means the light follow a single path through the core. It is called as single mode. And what is that graded is based on modes of fiber. We can classify the fiber as single mode and multi-mode. So mode, as I said earlier, it refers to the number of path for the light rays inside a cable. Okay, so single mode means if the light follows a single path through the core. It had a number of advantages that since it takes a single path along a fiber core, it doesn't show any dispersion. So no intermodal dispersion will occur here. And the capacity, information capacity while using the single mode fiber is also very large. But what is the disadvantage it had means while launching the light from fiber to fiber, it is very difficult, and its manufacturing fabrication is also very difficult. Since why we are telling the fabrication is very difficult means the light ray along a fiber takes a single path, so the core area must be very very small to take a single path. So while moving to the fabrication, it's quite difficult when compared to multi-mode. Okay, the next multi-mode, as I said earlier, multi-mode means the light takes many paths to travel along the core. It will takes a number of paths, hundreds of paths it takes. Okay, so what are the advantages of multi-mode fiber? Means the fabrication is quite easy and the launching. What are the disadvantage? We have given there in the single mode fiber, now it becomes advantage. Okay, so the launching of the light ray is very easy. Connection between the two fibers is also easy in the case of multimode fiber, but here the disadvantage is it suffers from intermodal dispersion, but it's one of an advantage of a single mode fiber, since it had a core area, that propagation guiding area is very narrow, very small line size, so there won't be any intermodal dispersion. But in the case of multimode, it is quite larger when compared to single mode. So what happened, it suffers from by means of intermodal dispersion. Thank you.